In this section, we are going to be adding and subtracting radical expressions, and just like we add or subtract in math, everything needs to be considered like terms in order for you to be able to combine them together. And in square roots and cube roots, in like radical expressions, we need the roots to be the same and the radicands to be the same. For example, we can't add like the square root of 3 plus the cube root of 3. Those are different because the roots are different. Also, we can't add together like the square root of 2 plus the square root of 3 because even though the roots are the same, the radicands are different. So the square root of 7 plus 5 square root of 7 minus 2 square root of 7, you literally would just do 1 plus 5, that's 6. 6 minus 2 is 4. Altogether, this would simplify to be 4 times the square root of 7. For part B, we have two different types of radicals. We've got square root of x's, 6 of them minus 5. So this would be 1 square root of x. And then we've got cube roots as well, and it's cube root of 4, negative 1 cube root of 4 plus 2 cube root of 4 would be positive 1 cube root of 4. The order in which you put your final answers does not matter. For the checkpoint question, we've got two like terms here. 3 cube root of x plus 2 cube root of x would be 5 cube root of x. And then plus square root of x minus 8 square root of x, that would be negative 7 square root of x, and then that would be our final answer. What happens most often, though, is we have radical expressions that do not have like radicands, and if that's the case, then usually they are set up specifically so that if you do simplify them, they will be the same. You just have to do some like preliminary work. So like the square root of 45x, I would rewrite that as the square root of 9 times 5x. To simplify this to be 3 times the square root of 5x plus 3 times the square root of 20x, I would rewrite this as 3 times the square root of 4 times 5x, knowing that I can take the square root of 4 out. When I do that, the square root of 4 turns into a 2, which gets multiplied by the 3 out front. So I'll show you each step, making this 3 times the square root of 5x plus 6 times the square root of 5x, and that would be 9 times the square root of 5x. And that would be our final answer. Part B, we've got a cube root of 54y to the 5th plus a different cube root, 4 times the cube root of 2y squared. Now the second one, the cube root of 2y squared, I know we have 4 of them, but that's fully simplified. There's nothing we can do there, but we will have to simplify the first expression. So when we're simplifying cube roots, we are dealing with perfect cubes. So to find a perfect cube, you take a number and you cube it. 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on. 1 to the 3rd power is 1, 2 to the 3rd power is 8, 3 to the 3rd power is 27, and so on. So in this case, 54 is 54 has a factor of 27, which is a perfect cube. So what I would do is rewrite 54 as 27 times 2, and then I'm going to rewrite y to the 5th power in groups of 3. So we would have 1 y to the 3rd, and we would have to have a y squared as well in order for it to work out to equal still y to the 5th power. So I'm just kind of rewriting that. And then I'm going to simplify. The cube root of 27 comes out and it turns into 3. And the cube root of y to the 3rd right here also comes out and it'll turn into a y. What will be left inside of the radical is the cube root of 2y squared, which is perfect because the other one is the cube root of 2y squared. Now they're the same. So what we would do is we would take these like terms and add them together. We've got 3y plus 4, which we haven't seen yet. But if we were to add these two things together, 3y plus 4, since they're different terms and we can't actually combine those to be one single number, we would need parentheses around them. And then this would be times like the whole thing, the cube root of 2y squared. That's how you would simplify that. And then the third one, we've got the square root of 7 minus 5 divided by the square root of 7. And the first thing I noticed is like if I needed to simplify this, we're not allowed to have radicals in the denominator. Now this radical is a square root, so to cancel out the square root of 7 in the denominator, what I can do is multiply both sides by the square root of 7, and that's because the square root of 7 is like the square root of 7 to the first. And if I multiply it by another square root of 7 to the first, it turns into the square root of 7 squared, which cancel each other out. So I would have here the square root of 7 minus 5 times the square root of 7, and then over the square root of 7 times the square root of 7, you can think of it as the square root of 7 squared, cancels out with the square root and the squared, it'll just be 7. You can also multiply them together. 7 times 7 is 49, which is a perfect square. So we'd have the square root of 7 minus 5 square root of 7 over 7. Now the issue with this is we should still be able to simplify this further. We have two numbers that we can think of as fractions. The second one was obviously already in fraction form. The first one wasn't. But to turn it into a fraction, I can put a 1 underneath of it, and we would have to find a common denominator. Well, this one is a 1, this one is a 7. Common denominator would be 7. I would just multiply both of these by 7, turning it into 7 square root of 7, a lot of 7s here, over 7, minus 5 square root of 7 over 7. And now I can go ahead and with fractions, I add or subtract the numerator and keep the denominator the same, so it's going to stay 7. 7 square root of 7 minus 5 square root of 7 is 2 square root of 7 all over 7, and that would be my final answer. Okay, and then the checkpoint questions. So we've got different radicals here, and they're not going to be the same. Let's rewrite these. So 5 times the square root of, since it's the square root, I'm going to break up x cubed into x squared times x. And then I've got minus x times the square root of 4x. And now simplify. So the square root of x squared really just equals x. And if you're confused with that and like not sure how to go about it, you can always break up your radicals like this. Like the square root of x squared times x is the same thing as the square root of x squared times the square root of x. And if that's helpful for you to be able to like simplify this part of it, then definitely do that. The first one will simplify to be 5x times the square root of x. And then the second one, the square root of 4 comes out, but if you wanted to rewrite this as like the x times the square root of 4 times the square root of x, you can do that. The square root of 4 really equals 2, so this is like minus 2x times the square root of x, which now we do have like terms. 5x square root of x minus 2x square root of x is 3x square root of x. Okay. And then for the second one, we've got cube roots here all along, so we're going to want to break up all of these numbers not into perfect squares, but perfect cubes. So the cube root of 6x to the 4th. Well, the perfect cubes was up on the last page, but perfect cubes we're dealing with 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on. So that would be 1, which is never helpful, 8, 27, 64, and so on. You might need a larger number, and you know, like sometimes you just need to use your calculator and figure out what it would be. But these are the types of numbers I would use to try and break up the regular numbers in the radicals. So for the first one, the cube root of 6x to the 4th, 6 doesn't have any perfect cube factor, so I'm going to leave it as a 6. But I'm going to break up, because it's helpful for me, x to the 4th power into x cubed times x. All right, I'm just going to go down the line and do all of them. I'm going to break up 48 into 8 times 6, and then I would have an x still, plus cube root of, I would break up 162, and I don't like off the top of my head know what goes into 162. Like I literally would take my calculator and do 162 divided by 8. Doesn't work. 162 divided by 27. It works. It would be 27 times 6, which is perfect. You're noticing probably the 6's in each one. And then breaking up the x to the 4th as x to the 3rd times x. Okay, now for the simplification process. If it's helpful, you can kind of maybe underline all the things that can be simplified, or however you want to do it. But the cube root of x cubed, that will be able to come out. The cube root of x cubed will come out of the radical and turn into an x. What we'll still have left, though, is the cube root of 6x plus. The cube root of 8 will come out of the radical and turn into a 2, and we'll still have the cube root of 6x plus. The cube root of 27 will come out as a 3, and the cube root of x cubed will also come out as an x. We'll still be left with the cube root of 6x. So the radicals are all the same, cube root of 6x across the board. What I would do is add up all of these other things. I've got x plus 2 plus 3x, so might as well combine together the x and 3x, that's 4x. And then we have plus 2, not fully like terms, I can't add them all together, so I'm going to put parentheses around that and put times the cube root of 6x as the final answer.